So more in that on your practice test. Okay, so practice on the Rydberg equation. Okay, so as said, in connection to Rydberg equation, you would see visible light when an electron emits na or proceeds from a higher orbital to a lower energy level. So meaning that is actually present in your this is actually happening in your metal ions. So sa mga flame test natin is actually an um, um, emission property of your electron. No? So as it moves from a higher orbital, so una, may excite mo na siya due to heat. Kaya 'di ba ang flame test is iniinit. Ang reason dun is to give your electron heat or energy to increase or to help it get to another higher energy level. So as it emits, as it go back to its original level or lower energy level, it would actually emit light, no? So depende ang color ng light depende sa identity of your element or your metal. Okay, so this is the common color for your metal ions flame test. You need to remember all of this because this typically appears in physical chemistry or in organic chemistry. Okay, about one or two problems could appear in your exam. Okay, so you remember the most common common ones. You remember sodium, calcium. Cesium is actually the god of clouds. Ata, so this is kaya siya mukhang blue, no? Um, Potassium is actually very famous na nakikita nyo your potassium. So, purple violet. Radium is red, strontium is bright orange, barium is light green, no? And copper is around green, iron is yellow. Okay, so you should remember your flame test. Okay, so more on your electronic structure of your atom. Okay, so as said, um, when an electron moves from a higher orbital to a lower over orbital, mag-emit siya ng light, no? Or it emits energy in the form of light. Okay? So, actually, meron tayong mga series when calculating for your wavelength which correspond to a um, line spectra. Okay? So, Lyman series is actually a series within the ultraviolet region. No? So if it emits light in the ultraviolet region, so hindi mo siya makikita. Ang iya NF lagi is 1. Okay? So if your electron moves back into your NF na 1, meaning Lyman series yan. Meaning, ang emission niya ng light is in the ultraviolet region. Okay? Ang Balmer naman is the famous one, no? Kasi it's within the visible range, 400 to 656 nanometers. So, ang final NF niya naman is 2. Okay? So, ang series, if an electron moves back to an N equals 2, then that electron would produce light, no, within the visible range. So, Balmer series siya, okay? What if naman, ma'am, nag-move siya to an n is equals 3? So, when an electron moves back to a final energy level na 3, then ang emission niya is Paschen series, no? So, ang emit niya naman dito is actually your infrared light, no? So, NF of 3, okay? So, Layman is ultraviolet. Balmer is your visible range, no? Passion is your infrared, okay? You can actually calculate for these values if you plug it in here, okay? You can calculate this value and you would get the same wavelength, okay? Palitan nyo lang yung NF. Depende sa, kung layman, then you change it to n equals 1, okay? And you put any ni here, okay? So that's basically it. Okay, so remember Layman, Balmer, and Passion series. So actually, the orbital diagram of your series kanina is actually not correct, no? Kasi ginadepict niya na each energy level are equal. So equal ang spacing daw, which is not the case because every emission of light correspond to a different wavelength, meaning different din ang frequency and energy gap, no? So this is the more correct model for your emission of light, no? So you have your ultraviolet, so medyo mahaba ang energy gap niya. Okay? Your visible is to n is equals 2. So the second longest, no? Your passion naman is to your infrared. Bracket is n equals 4 and p font is for your n equals 5. So hindi actually correct ang model na circular, okay? More on mas correct to kasi pinapakita niya ang energy gap between different orbitals, okay? So meaning ibagad ang light na na-emit in correspond to the frequency and the energy gap, okay, present in the orbital, okay, and the transition made by your electron. Okay, so this wave number correspond to the wavelength correspond to the wavelength calculated when you start plugging in the NF and NI here sa Rydberg equation. Okay, it only works with a hydrogen-like atom such as helium plus. Okay, so yes. Okay, more on that, you have your hydrogen spectral species or series. Okay, emission of spectrum of hydrogen when an electron jumps to an N. Okay, so you have your Lyman, Balmer, Paschen, Brackett, and Phi-Fund. I should memorize their specific region on this spectrum. Okay, so you have your ultraviolet, violet to visible to ultraviolet region, infrared, and your infrared naman para kay FIFON. So, Lyman, Bulmer, Passion, Bracket, and FIFON. Okay? Wherein your N is equals to 1 for your Layman and is equals to 2 for your Balmer and 3 for Passion, 4 for Bracket, and 5 for FIFON. Okay? So you memorize your spectral series for hydrogen-like atoms. Alright, so more on that. So you have your sample problem. You can pause this video and start answering. Okay, if the electron of an hydrogen-like atom goes from the second to the first shell, what is the amount of the energy released? Okay, so you use your Rydberg equation to answer this question. Okay, so if you answer correctly, you should have this solution. So first you write your Rydberg equation. Your Rydberg equation is the reciprocal of your wavelength, no? So pag nakakuha ka dito ng sagot, hindi pa yun yung final answer mo, okay? That is actually your wave number. If you take the reciprocal of your answer, then you would have your wavelength, okay? So what is the amount of energy? Since ang hinahanap is energy, then you need to correlate the wavelength to your energy. This is formally known sa equation na to, no? In correlation to your energy, which is your Planck's constant, speed of light, and your wavelength. This is your energy of your photon, okay? Of photon, okay? Or energy release, okay? So your Planck's constant is 6.626 times 10 raised to negative 34 joules per second per electron. Okay, so ang Planck's constant mo is actually depende sa particle mo. This could be your proton, neutron, or electron. In this case, electron. So since the electron, so one electron lang, so dapat mag-multiply kayo dito ng one electron to cancel out this electron. And since gusto mo ng energy, so that should be joules, no? Dapat makancel din ang seconds mo, which is actually correct kasi you're using speed of light, no? Which is meter per second. So, meter cancels out sa bottom. Seconds cancel out. So, you are ultimately left with your joules, okay? So, 1.63 times 10 raised to negative 18 joules ang sagot. Okay? So, you use your Planck's constant times your speed of light times how many electrons are involved in the problem. Since sinabi na the, meaning one electron lang. Okay, one electron. Right. Over your wave, all over your wavelength. Okay, which nakuha mo from your Rydberg equation. Okay, so that is how you solve this kind of problem. Okay, is actually a problem when describing electron merely as a small particle circling the nucleus. As we will see later, Electrons exhibit wave-like properties. As a matter of fact, any acceptable model of electronic structure must accommodate that electron can behave as a wave. It was actually Albert Einstein who um, hypothesized on the theory that light could behave as a particle now. Ang tinawag niya dito sa experiment na to is the photoelectric effect. Okay? Um, in this experiment, when a beam of light of a certain frequency strikes the metal surface, electrons are emitted or ejected from the metal surface. This phenomenon is known as the electric or photoelectric effect. Okay, alright, so proving that light behave as a particle. How so, ma'am? Okay, so sinabi dito, when light is shown or shine towards a metal surface, electrons daw are emitted. Electrons are displaced towards a certain direction. In this case, naglagay sila ng detector um, to detect that electrons are actually emitted, no? Kasi if you have electrons, then you could actually have a current, no? So, amo na ang purpose ng ammeter, no? Every time light is shown in this metal surface, specific wavelength of light or frequency of light is shown here. Electrons are emitted, no? Are displaced. Okay? Paano nila detect? Naglagay sila ng detector measuring the current, no? Okay? So this experiment actually proved that light can behave as a particle because um, electrons nga are displaced sa metal surface. No? So those are properties of a particle, which is shown, which is actually exhibited by your light. Okay, so this is your photoelectric effect. Okay, perfect example of your photoelectric effect is actually your solar panels. No, it converts light into electricity with the help of the ito nga, photoelectric effect. Okay, ang principles in solar panels is actually your photoelectric effect, thanks to Albert Einstein, proving that light could behave as a particle. Okay, so, ano po ba ang quantification or equation proving the theory of photoelectric effect? Okay, the kinetic energy of electrons emitted is directly proportional to the frequency of the striking photon or of the light and independent of their intensity. Um, More so, this could be written algebraically as E energy of the incident light equals the threshold plus the kinetic energy, no? Where your kinetic energy is actually associated with motion. Kaya nga, di ba, may displacement of electron kasi kinetic energy is actually associated to particles. I'm proving that light could behave as a particle. Okay, so you have your work function, no? Work function is the minimum energy required to remove electrons from the metal surface corresponding to a minimum frequency called the threshold frequency. So na-discover ni Einstein that not all colors of light can remove electrons from the metal surface because may minimum energy required lang to remove an electron. And that work function actually depend dito or varies depending on the metal that you use. Okay, so every metal has a different work function. Okay, so it correlates to the frequency, again, your threshold frequency. Okay, all right, so this is the equation. You have your energy equals your work function plus the kinetic energy. Okay, so what will happen when the total energy is bigger than the work function? What if you use light, you use a certain frequency of light that is beyond the work function of your metal? What will happen? Okay, kaya naglagay dito ng kinetic energy because um the excess energy could actually transform into your kinetic energy, which is actually the conversion of energy, diba? Okay. So the minimum function or work function has also a corresponding minimum frequency. So minimum frequency, this is one, the minimum frequency. So every work function of your metal has a corresponding work function. Threshold frequency multiplied by the flux constant. Okay. So if may sobrang energy from your photon of light, it will be transformed